this computer. Excuse me. I'm really sorry. Okay. Okay, great. So at this point, this point that we reached the last time. So I will ask you to type on your browser tinkercad.com, and once you go through this website, you have to sign in. Sorry. So I have to send the www.tinkercad.com. I will send it to all of you. Okay, so please copy it and open it in your browser. Okay, and then after I will make a logout in order to be like you, in case you don't have. So once you log in to you type tinkercad.com, you will have this this welcome screen. So you can click on sign in, and here you have the options of choosing between sign in with Google or with a username. So as most of the students have a Google or an email or a username, so I will click with the Google. I will choose my account, and like this you will have to do, or your students will do. And once we are in, okay, you have three sections that you can manipulate. You have the 3D design, the circuits, and the code blocks. So I will go directly to the circuits. Hope you can work in parallel with me. So once I click on circuits, I have all the circuits already done previously, and this is good for each student since they will keep all the projects for them in case they want to open them in a later stage. I click on new circuit, and once I click on new circuit, I can start exploring my program using even Tinkercad, even Arduino or microbit. So why it's not changed? Yeah. Please, can you raise your hand to tell me if I'm sharing my screen, because I'm sharing my screen. Maybe it's a yes, it's sharing. The one who asked this question. I can. Okay, great. Okay, so for those who are not seeing my screen, maybe it's an internet connection. Try to turn off some devices from Wi-Fi, like the phones, the tablets, so you can see this screen. So once I go through my page, I can scroll down, and as I said before, the only two boards adopted by Tinkercad are the microbit and the Arduino, and from here you can know how much it's important, those two brands. What I'm trying to say, if someone came and convinced you to adopt another microcontroller, please do not, since if you adopt a microcontroller X, it will not be included in the Tinkercad, so your students will not be able to manipulate those or the board that you adopt. I highly advise you go for Arduino and you go for Tinkercad, and we can help you to have those two boards in your at your school. So I can move directly a microcontroller microbit, but I will show you how I can, with a simple circuit, by moving a 9-volt, and you can do it right now with me. I can take the 9-volt, and here you can see that directly the displayed pole will be on the screen negative and positive. I will be moving a LED, and this is the cathode and this is the anode. The cathode will be connected to the negative pole, okay, as you can see here, and the anode to the positive pole. And if I click on start simulation, the LED will blink, and there is a warning message. Current through the LED is 915 milliampere, while absolute maximum is 20 milliampere. So we are giving too much current to the LED, it will burn out. That's why you can introduce the notion of I will stop my simulation, the notion of the resistor, that I will delete this cable, this wire, I will connect it to the LED, to the resistor, and then connect it here. And once I click on the start simulation, you can see that the LED is blinking without any, give us one simple example. It's Noura, Mrs. Noura, this is a simple example of what you can manipulate to start making the students understand electricity in lower grades. It's the simple example that you can have ever. It's to connect a LED to a battery, and to add a resistance or a resistor, sorry. Okay, depends for which grade you are teaching, 6 or 4 or 5. So you can integrate the idea of the resistor. And I will move right now to another example. So this is the first example that you can review it in your recorded session that will be on YouTube. So with this part, okay, you will be adding the push button in order to control the light once you click on the push button. So I will delete this wire. I will connect my resistor to this side of the push button. I will make it a little bit bigger. And from this side, so as you can see here, the connection, it's not me who decided. It's like this, the push button, it's the wires are connected in a diagonal way. So I will click here on this terminal and I will link it to the positive. And once I click on the start simulation, the button or the LED will not illuminate. Once I click on the push button and I release, it will illuminate, as you can see right now. Okay, there is people who are asking me that they don't have the microbit. Okay, right. You didn't share the screen. Mrs. Tahrir, I'm sharing my screen. I don't know, maybe the problem is from your side. Maybe the internet is a little bit slow. Are you raise your hand to tell me if I'm sharing my screen or not? Okay, as you can see, many participants are raising hands saying that they are seeing my screen. So the problem is from your side. So till now, we saw one example using the LED. Okay, thank you. So the other example is by adding a push button. And as you can see, if I click on the code, you see that no programmable component in the circuit. It's normal. And you have to know that since you don't have a microbit or any other component like the Arduino, so you cannot program those components. It's just by showing students how to make this circuit. So I will delete all the components here. I will move. This is my third example. I don't know if you are reaching the manipulation with me. In all cases, this session is recorded. You can watch it later on and practice on it. And what we are doing with you right now is what you have to do with your students. So I moved my microbit. If I click on the code, all the blocks that I saw on my the make code program are available here. So you can do any manipulation you want. Let's say if you want, by default, you have two blocks, which are the on start and the forever. So on start will execute the block that are inside the moment you launch the simulation. As you can see here, the smiley face is done. And in the forever loop, information will be executed in a continuous way. So here I can do as many examples as I want. Let's say if I want to make the program, if I click on the push button A smiley face will be displayed, or if I click on button B, a heart will be displayed. So I go to the block section. I from the input, I choose the on button A, and from the basic, I select, let's say, the icon, and I choose the heart. And if I click on start simulation, once I click on the push button A, the heart will be displayed. And if you want to duplicate again those blocks and change here the button B, and to display, let's say, the X symbol. So if I click on the start simulation, once I click on the A, the heart will be displayed. And if I click on the B, the X will be displayed. So here is a simple manipulation of how can I merge between the input and the output device. And as you can see, directly the microbit sensors are displayed, the temperature sensor, the light sensor, and the shake sensor are displayed directly in order to make, here is the compass. If you turn it like this, so it's possible for you to create a specific manipulation. So I believe this section will not be really tough for you. I will take this opportunity. To okay, so Mrs. Buthaina sent again the Tinkercad website for simulation. I will take this opportunity to create a program more interesting than manipulating the board by itself, which is to connect from outside a LED, for example. So as you can see, there is the option of moving a LED. I will move the LED here. Okay, and from the bottom side of the Arduino microbit board, you have the digital pins. The digital pin 0, the digital pin 1, 2, the 3 volt for giving a current, and the ground. And as you know, or the teachers that have participated to the Arduino webinar, you can see that the Arduino gives us the option to connect 13 digital pin. Here we can connect only 3. It's normal since it's a board for beginners, for lower grades and middle classes. So no need to make really what we call advanced projects. The idea, and I say it again and again, the idea of integrating the microbit is to make students introduced to the microcontroller world, and later on it will be simple for them and easy for them to understand the world of Arduino, which is more complicated and more professional. Sorry. So I will try to connect the cathode, which is the negative pole, to the ground. Okay. And as you can see, it's very simple. You can connect directly the anode to any of the digital pins 0, 1, or 2, or you can add a resistor. It will be the same since it's a simulation, so no problem, or you will not be afraid to burn out the LED. So I will connect it to digital pin 2, and here I'm ready to what? To start working by program on the LED. And this is what the students should do as manipulation. So I will go to the code. Okay. I will keep on start the show icon. I don't know, the smiley face. And in the forever loop, I will go through the output, just to remember. And as you can see here, the digital right pin, I will move it. I will select the pin. You see here, I don't have more than 3. In Arduino, I have 13. Set it to high. I will select from the category control, I think from basic, of a little bit, it's the wait 1 second. I will duplicate the 2 blocks and I will make it low. And once I start the simulation, you will see that the LED is blinking. It's not very shiny since the resistor is not the adequate one. So I will stop the simulation. I will go through, I will click on the resistor. And as we said with Arduino, the appropriate size or type of resistor, value of resistor is in ohm 220. If you ask a teacher in physics, he will tell you why this calculation or how this calculation is made. So once I click on the run again, you will see that the LED is blinking better than the first time, and this is normal. It's always a blinking. Of course, you can add more control to this circuit by stopping the simulation. And in case you want to add a control by the push button, you can go through the input and you select, if the push button is pressed, I will move all this inside and I will duplicate all those blocks. I can remove this one and even this one. And I will select here, if the B is pressed, I will delete this part. I will put my LED on. And if the A is pressed, I will turn it off. Okay, so believe me, your students will enjoy a lot this manipulation. And the idea of doing this manipulation online, they will take it with them home and will try to explore this manipulation or those manipulation with their parents, and your feedback will be amazing. So please, can somebody send me in the chat to remind you, to provide you with the extra worksheet for the microbit in Tinkercad, since in the book we've developed the curriculum using the make code, not the Tinkercad, so you can work both with the two. So I'm waiting from you in the chat. One of you can send me to remind you. So if I click on the start simulation right now, so I click on the button A, on the button A. On the button B, it's illuminated. On button B, it's off. So I can make a control here, as you can see on the LED. It's amazing, no? So imagine your students, your kids in grade 4, 5, and 6. they start to control, to create a simple circuit, as simple as that, and believe me, they will not find it anyhow hard to manipulate. And we start controlling the buttons, the LED using the button, okay? And what if you want to control the light using the sensor of, sorry, what if to control the LED using the light sensor? So let's try to make it together. I don't know if you are working with me, but just to see where I can find the input. So here you can see the light level. This is this manipulation. I'll tell you from now that it will be a little bit advanced, since I will be using the comparison block with the light level sensor. It will be funny for you. It will be funny for your students in grade 6 and up, maybe 5, but not lower. But it's really important to show you and to watch how it's feasible with the microbit. So what I'll be doing here in my new manipulation is to control the LED to turn on and off by the level of light which is around us in the room. And by the way, you can give such an example of the street lights outside, where they are illuminated automatically when it's night. So this is the same example that can be applied, and you can tell your students that on the street lights outdoor next to our houses, there is on the light a small microcontroller that measure the intensity of light outside and will order the LED to illuminate, or the light or to illuminate once it's dark, let's say. So how I will do it? Of course, I will need the light level, as you can see here. Okay, and I will go up with the control, and I will take the if statement. I'll be happy to see if you are enjoying this session. You can raise your hands. Also, it will make me a pleasure, like if I won a $1 million today. So thank you for your motivation, and I'm really enjoying today. So I will take the if statement. I will put it in a forever loop. Okay, as you can see. And if in the condition, I will try to create a comparison block. So I will try to find where is my comparison block. It's in the math, it's normal. I will move this block, which is the comparison. I will place it I will replace the true with this comparison block. I will place the light sensor, the light level in the first part, and I will choose the greater than, I will say 30. What to do if the light level is higher than 30? I will turn off my light. I consider that it's day, and if it's less than 30, I will put my light high. Okay, look how I will delete this block and this block, no need for them. And look how for this simple scenario, I'm controlling my LED using a sensor. So can you imagine in lower grades when students start understanding this concept? Okay, it will be easy for you. And when they are making this mixture of coding part, electronic parts, and circuit part, you are helping in creating students that will understand more and more this technology. So if I click on the start simulation, which is good in Tinkercad and even in MakeCode, it's the same, is that once I click on and I make, you can see that if it's less than 30, the light will illuminate, the LED will be on, and if I place it higher than 30, okay, the light will turn off. So it will be automatic. Since we are doing this as a simulation, okay, it will be done on the screen. But if we have the real board and we place the program on the real board, so you can do it. And we can make here, for example, we can make it by placing the show LEDs in a funny way. So if you can again place you can see you turn off even the LEDs here, and I forget to place another block just in case it was high to make it off. So as you can see here, the light will illuminate, and the screen will be illuminate, and then it will turn off. To tell you that there is Mrs. Amal is asking me, we need some projects ideas that suit grades 4, 5, and 6. Of course, you have and Gosha is asking that in grade 5 digital resources there is no data. I know that, and I will be starting from today to put it. It's a mistake from it's a missing from us. So as you can see, we cannot imagine how many examples we can do by working even on Tinkercad or on what we call the MakeCode program, on virtual and on the program by itself. I will not be late. I will try to finish it in maximum 5 to 10 minutes. I think it's time now, and I know you are in vacation, so I will not keep you waiting too much, knowing that you are enjoying your presentation. My presentation, sorry. So what I'm going to do right now is to show you, for example, a program that I've did to make a game between two students. Let's see it here. I've created the program on Shake, which I can find it in the input category. All those blocks are the same in the MakeCode and in the Tinkercad. So I moved the on-Shake program from the category basic. I moved show number. As you can see, it's the same. And from the category math, I select the block pick number from 0 to 10. Of course, you can change the value. I mean, you can place it from 0 to 6. Okay, and once done, you can. I'm facing a problem with my mouse. I can here. I have to switch to the camera of my. Little bit lost here. Okay, I think you are seeing my my board now. No, I cannot see myself. Can you raise your hand to tell me if you are seeing my my board, please? I think yes. Where is my board? Okay, great. Okay, excellent. Okay, good. So here what I'll be showing you is once I click on the download here, okay, the program, you can see that the LED is blinking. I have to watch my screen. I don't know what it's scrolling. Okay, so and if I start moving my on shake, maybe I have to delete just 1 second. Forever. Sorry, I have to delete this one. Okay, excuse me. So I click on download again. You will see the orange or the yellow is flashing, and once it's done, I can shake my. You see the number 6. You see the number 0, 3, 6, 1, 5, and so on. So what I'm trying to show you here, and even here, if I click on the shake button, 1, 2, 1, 3 on the screen. Okay, so look how it's very easy by teaching microcontrollers. Even if you have the physical board at this one or you don't have it, all the manipulation could be done on my screen or on my board, so no worries about it. Like this, for example, we can make a game, okay, but between 2 students by picking random numbers in order to complete the game. So you can imagine a specific scenario. Of course, it's the beginning with the microbit. We have too much to explore by using the variable, by using the LED, the function plot and unplot, which allows us to make students understand at lower grades. For example, if I go through the block forever, and I go through the LED and I move the plot, and then after I make it pause, and then the LED unplot, and as you can see here, duplicate, as you can see, each one of those LEDs have let's say the coordinates X and Y, okay? And imagine how motivated will be to make students understand the concept of in math. And since I know that some of you are math teachers also, the X and Y coordinates in a matrix. So here the first LED is 0, 0. This one is 1, 1. This one is it's not working right now, but this one is 4, 4, and so on. So imagine how you can create this algorithm. I will finish by this information, how you can create the algorithm using, and it could be done with grade 6, and it's included in the curriculum of grade 6 in your book. So in case you want to integrate variables that are changing and incrementing by using the microbit. So you see, you have many of the features and skills that you can teach in math, in circuit, in programming, in STEAM projects. All you can do them by working with all those components. Before I finish my presentation, I will remind you again that just give me 1 second, that till now there is 68 people who send me requests to have the certificate of participation, I will send it back again, the link to the chat in case someone did join late and he did not send his information in order to print him and to send him the certificate of participation. So in the chat now, you have all the link to register for the certificate of participation. It's different than the first two, since I found that it's a little bit complicated to manage them. Here it's better, and I highly advise you to go to this website, to this link, youtube.com/linfoportus.com, sorry, Linfoportus online. This is our YouTube channel. I highly invite you to subscribe to this channel in order to receive all what we've uploading. There is hundreds of tutorials that you can use for students in all the topics, in microbit, in Arduino, Excel, PowerPoint, Scratch, robotics, Python, small basic, all the robotics. And in the email, Mrs. Razan, please, for this one, please send it by WhatsApp, by the Google form. The previous was sent by email. So just give me one second. 1 second, please. Okay, so as I said, I've sent you the link to request the workshop certification. I've sent you the link to subscribe to the YouTube channel. I will be sending you by email the link, the PowerPoint link. You are asking for the PowerPoint link. Give me just 1 second. Maybe I can share it with you right now. The PowerPoint, the microbit, the PowerPoint, the microbit, January. Okay. Get the link. Just give me 1 second. Maybe I can send it to you right now on this, and later on I will send it by anyone. Copy the link. Done. Yes, Muhammad, I will be answering all your questions in case. The link I sent you right now is to download the PowerPoint for the microbit. For the time being, I'll stop, since we took more than 1 hour. I will stop the recording first.